Welcome back, everyone, to the UCSD CSE database seminar. Today, it's my pleasure to have Julia Stoyanovich. She's an assistant professor at the New York University. She's going to be teaching us about responsible data management and what the data management community can do in this broader push in society for more ethical, responsible, fair use of data-driven decision systems. Julia has done a lot of exciting work in this space. She has already given a keynote at the prestigious VLDB conference about this topic. So we'd like to hear more from Julia, and hopefully this is beneficial for the whole audience. So with that, I will hand it over to Julia. Please take it away.
Thank you very much, and thank you for having me. So I'm going to once again, I'm sharing, right? So
yes.
And how much time do I have?
Oh, okay. So this is the protocol. Usually we do like 50 minutes of talks and 10 minutes of Q&A. Would you like the questions during or at the end?
Now let's see how it goes. I think we can pause for questions.
Okay, great. Sounds good.
Yeah. So if there are questions about something like, oh, so you said the word bias, what does it mean? Hold those, please. But I'll pause at kind of natural places to make sure that we can interact.
Sounds good. Okay. And
another thing is that I unfortunately don't see you because I use Keynote and it just takes over your entire screen.
Oh.
So if anybody has a burning question, please just speak up.
Okay. I will also monitor the chat and the audience hands and stuff. So audience, if you have a question, feel free to raise your hand and I will interrupt and make sure that it's asked at an opportune time.
Great.
Thank you, Julia. Take it away.
Okay, good. So it's a pleasure to be here. I am showing you here my affiliations, of which one is a new one. So I'm an assistant professor of computer science and engineering and of data science at NYU. And also, as of a month or so ago, I direct the newly established Center for Responsible AI at New York University. Today I will tell you about some recent research, but perhaps even more importantly, the framing of how we can make, or how the data management community, and more generally the technical community, can help usher in a time where responsible AI is synonymous with AI just generally, so that we don't have to qualify it. And the compulsory introductory slide is that, of course, AI is wonderful. It's absolutely great. It's the best thing after sliced bread. We have enormous computational power, enormous data collection capabilities. And also data collection and data analysis are, of course, broadly accepted in society. And so this gives us the power and the opportunity to do a lot of good. And the opportunities are numerous, as we all know. We can accelerate how science is done in a variety of areas, including astrophysics, but also perhaps more relevant to today, medicine and public health. We can boost innovation in a myriad of ways, from self-driving cars to advertisement targeting and back. And we can improve how we govern, how governments function. And this is an area that is of particular interest and importance to me personally. We can specifically use data and algorithms to help make resource distribution more equitable and to help bring greater transparency and accountability to government operations. And perhaps most importantly, we can get AI to do all of our work so that we can just sit back and relax at the beach. And to make our discussion today concrete about the power and the opportunity, but also some of the dangers that automated decision-making can bring, I'm going to focus on a particular domain. And this is a domain in which I have been doing quite a bit of work lately in terms of both technical work, but then also education and policy. And this domain is automated hiring systems. So what are these automated hiring systems? In a recent report from a think tank called Upturn, the hiring process that takes place these days broadly in the world, but also specifically at major employers, can be represented as a series of decisions that form a funnel. This funnel is a system that is operationalized as a sequence of data-driven, algorithm-assisted steps in which a series of decisions culminates in job offers to some candidates and rejections to others. The process starts when employers source candidates, for example, by placing ads or job postings. The next stage is screening. This is where employers assess candidates by analyzing typically their resumes or their LinkedIn profiles or their online presence, by analyzing their experience, skills, and characteristics. Through interviewing applicants, employers continue their assessment in a more direct fashion. Then a background checks step very often would follow. And during the final stage, which we call selection, employers make final hiring and compensation determinations. And what's important to us here, not only as people who sometimes need to look for jobs, but also as researchers and practitioners in this technical field, is that data and predictive analytics are used very commonly during all of these stages. As was stated by Jenny Yang, who served as commissioner of the Equal Employment Opportunity Commission, or EEOC, under President Obama, automated hiring systems act as modern gatekeepers to economic opportunity. And now some bad news. One of the earliest indications that there's cause for concern came in 2015 with the results of the Ad Fisher study out of Carnegie Mellon University that was broadly circulated by the press. The authors ran an experiment and found that ads for high-paying jobs were shown far more frequently to men than to women. And this was actually not real men and women, but rather synthetic profiles of web users who in fact were indistinguishable in every other way other than by their stated gender, which was binary in this study, and it was either male or female. And this observation brings back memories of the time when it was legal in the United States to advertise jobs by gender in newspapers. This practice was outlawed in this country in 1964, but it persists in the online ad environment today. Let us now advance to the next stage of the hiring pipeline. This is resume screening. And this study, this investigation, I'm sure is familiar to quite a number of you. In late 2018, it was reported that Amazon's AI recruiting tool that was developed with the stated goal of increasing workforce diversity, in fact, did the opposite thing. This system taught itself that male candidates were preferable to female candidates. It penalized resumes that included the word women's, as in women's chess club captain, and downgraded graduates of 2 all-women's colleges. And interestingly here, despite the essentially unlimited data resources, computational resources, and talent in its AI workforce, Amazon was unable to mitigate this issue of gender bias in hiring by means of a purely technological solution. Other examples of discrimination include shutting out people suffering from mental illness, such as depression or bipolar disorder, on the basis of online personality tests. And this happens even if these individuals have the right skills for the job. So this is discrimination based on disability status. Another example that is later yet in the hiring funnel and that is quite striking, that can occur perhaps during a post-interview background check by a potential employer, was surfaced by Latanya Sweeney, an African-American computer science professor on the faculty at Harvard, who showed that Googling for African-American sounding names, such as her own, is more likely to trigger ads suggestive of a criminal record than if you Google with white sounding names. And this happens even if you control for whether an individual whose name you're using, in fact, has a criminal record. So to summarize, despite their potential to improve efficiency for both employers and job applicants, automated hiring tools are also raising concerns. These concerns pertain to essentially two dimensions that are related to each other. One of these is unfairness in the decisions that are made by these systems, and we denote these concerns by discrimination. And the other set of concerns has to do with unfairness in the process by which these decisions are made, and these are due process concerns. Very often, discrimination and due process concerns are linked to the term bias, and this is a term that I will revisit throughout my talk today. In addition to discrimination and due process, there are also questions about whether these tools in fact work. I'm showing here Arvind Narayana. He's a computer science professor at Princeton who has a very interesting talk that I highly recommend to everyone that speaks about AI snake oil. So the question here is, are these tools actually picking up useful signal from the data, or are they an elaborate coin flip at best and a discriminatory one at worst, or at what we're seeing today in reality? Stepping outside a little bit, in the complex ecosystem in which these automated hiring tools are commissioned, developed, and used, we should ask ourselves who is responsible for ensuring that these tools are built and used appropriately. Who is responsible for catching and mitigating discrimination and due process violations, and for controlling for proliferation of this AI snake oil under the fancy label of data science and AI. And as you can see by my culpability lineup here, in my opinion, everybody is responsible. And my talk today is aimed at helping all of us understand what responsibility we as technologists carry in this whole ecosystem. So in response to the question about responsibility, there has been much activity in putting forth ethical guidelines and frameworks, and also in making attempts to regulate the use of data-driven algorithmic tools, such as those that make part of the hiring funnel. This activity is much broader in scope than algorithmic hiring, so I'm going to step back for a moment and give a more systematic view by discussing automated decision systems, or ADS. So one of the kind of complexities or issues with people understanding how to regulate ADS has been in our inability to come to consensus about what an ADS is. What is the definition of an automated decision system? So here I'm making an attempt at such a definition. The hiring funnel, as well as each component of the funnel, are examples of ADS. These systems have the following characteristics. They process data about people, and some of this data may be sensitive or proprietary. They help make decisions that are consequential to people's lives and livelihoods. They usually involve a combination of human and automated decision-making. They are designed with the stated goals of improving efficiency and promoting, or at least not hindering, equitable access to opportunity. And finally, they are subject to auditing for legal compliance and at least potentially to public disclosure. ADS may or may not use AI, although most of them are built as AI because AI sells. And they may or may not have autonomy, meaning that it's not very common for these tools to make determinations on their own. There's usually also a human in the loop. But all of these tools rely heavily on data. And this last property is what I think puts ADS regulation, design, development, and deployment firmly within the purview of the data management community. So how might we go about regulating ADS? And should we even attempt to do this? While the predominant sentiment in the industry is still that regulation will stifle innovation, industry alone luckily doesn't get to decide. And even in the Silicon Valley, the need for meaningful regulation to ease compliance and limit liability is starting to be more and more broadly recognized. There's much debate on a specific regulatory framework that we should use. Should we use precautionary principles that can be summarized as better safe than sorry, or more likely attempt a more agile risk-based methods, such as algorithmic impact assessment. All this and more is the subject of intense debate, some of which I had a chance to witness and participate in firsthand. New York City, where I live, recently made a very public commitment to opening the black box of the government's use of technology. In May 2018, an automated decision systems, or ADS, task force was convened in the city. It was the first such effort, the first such task force in the United States. And it was charged with providing recommendations to New York City's agencies, government agencies, about becoming transparent and accountable in their use of ADS. And of course, this is just a citywide effort, right? This is not at the level of a state or federally, but New York is a very large city. It's the size of a smallish European country. And whatever happens in New York, of course, people see worldwide. And so this was an important effort, despite its local character. This task force issued its report. And so I actually was a member of this task force, I should say. This task force issued its report in November 2019, making a commitment to using ADS only where they promote innovation and efficiency, not just using them because they are available, meaning we don't want to actually have this proliferation of using AI just because it's there. The second set of principles concerns promoting fairness, equity, accountability, and transparency in their use. And the third principle is about reducing potential harms across the lifespan of ADS. And I'm highlighting here the lifespan deliberately. And this is because, of course, we in data management have a better insight into what the lifespan and the life cycle of ADS development and deployment looks like. So I'll return to this point. And very quickly, there's also an ongoing activity on ADS regulation in New York. So just this Friday, there was a hearing at the City Hall at which several of us testified that concerns a proposed bill that would regulate the use of automated employment decision tools, or these hiring ADS that I spoke about at the beginning of my talk. And this proposed bill is actually very interesting. If passed, it would be the strongest such law that we know of in the US for sure, and possibly also more broadly. If passed, this law will prohibit the sale of automated hiring tools if they were not subject of an audit for bias. And it will also require any person who uses automated employment assessment tools for hiring and other purposes to disclose to candidates that they were evaluated with the help of a tool and not by a human. And finally, it would also be required that job qualifications and characteristics for which the tool was used to screen be disclosed to the job applicant. So with all of this in mind, we want to ask ourselves now, these are all nice principles, but what can we actually do? Can these principles of the responsible use of ADS generally, and hiring ADS in particular, be operationalized, enacted as a matter of policy? And what will it take to instill responsible ADS practices beyond government? Finally, what do we, members of the technical community, have to contribute to this conversation? Before diving into research challenges and directions, I want for us to step back and think carefully about the role that technological interventions, such as data management solutions, can play in supporting the responsible use of ADS. This discussion is necessary to help us find a pragmatic middle ground between two harmful extremes that are depicted here. On the left, I'm depicting techno-optimism, and that is a belief that technology can single-handedly fix deep-seated societal problems, like structural discrimination in hiring. And on the right, we have the other extreme, and that is techno-bashing, a belief that any attempt to operationalize ethics and legal compliance in ADS with the help of technology will amount to fair washing, and so should be dismissed outright. In summary, I want us to develop a nuanced understanding of this space. So this is why I hope that we're here today. So to start with this framing, let us recall the concerns about discrimination, specifically discrimination in outcomes, in algorithmic hiring. And we have been using the term bias to refer to these problems. What is in common between these examples that we saw of things going wrong? These can all be seen as examples of there being bias in predictive analytics. So what do we mean by bias? Our meaning of the term here is not in the traditional sense that is used by statisticians that says that a model doesn't fit, that is biased if it does not summarize the data correctly. Instead, what we're talking about here is that there are cases where societal bias exhibits itself in the data. It may mean that data does not represent the world correctly. So I'd like to unpack this further. Data is an image of the world. It's mirror reflection. When we think about societal bias in the data, we interrogate this reflection. One interpretation of bias in the data is that the reflection is distorted. We may systematically oversample or undersample in particular parts of the world or otherwise distort the readings. It's important to keep in mind that the reflection cannot know whether it's distorted. That is, data alone cannot tell us whether it's a distorted reflection of a perfect world, a perfect reflection of a distorted world, or if these distortions compound. The assumed or externally verified nature of distortions has to be stated explicitly. Another interpretation of bias in the data is that even if we were able to build an instrument that reflects the world perfectly in the data, it takes a perfect image of it, then it would still be a reflection of the world such as it is, and not how it should or could be. And importantly, it's not up to data or algorithms, but rather up to people, individuals, groups, and society at large to come to consensus about whether the world right now is how it should be, or if it needs to be changed, improved, hopefully, and if so, how we should go about improving it. My final point here is that changing the reflection does not always change the world. If the reflection itself is used to make important decisions, for example, whom to hire or what salary to offer to an individual being hired, then compensating for the distortions in the data or in the algorithmic process is worthwhile. But the mirror metaphor only takes us so far. We have to work much harder, usually going far beyond technological solutions to propagate the changes back into the world, not merely brush up this reflection. To illustrate these concepts, finally, I will now give some examples of recent technical work on algorithmic fairness and diversity with a focus on my favorite gadgets that are very natural in our running example scenario hiring. And these are set selection and ranking. Consider the task of selecting 4 candidates among 16 job applicants. Our goals here are twofold. The first is what we're going to call diversity, which I phrase as we wish to include 2 candidates of each gender and at least 1 candidate of each race. Our second goal is utility, which I will express as maximizing the sum of scores of the selected candidates, subject to diversity constraints. You can see a list of candidates in the table here, along with their scores. For example, candidate A has score 99, is the highest scoring, so the best according to score candidate in our data set, while candidate L has score 83. This is the lowest scoring candidate we have. Observe that in my example, male candidates have higher scores than do female candidates of the same race, and that whites have higher scores than blacks than Asians. The highest scoring set of 4 candidates that satisfy the diversity constraints that I posed is highlighted here in pink, and its combined score happens to be 373. If we consider the selected set more closely, however, we might observe a problem. And that problem is that we picked the best, according to score, white and male candidates A and B, but we did not pick the best Black, Asian, or female candidates. And note that my example here was deliberately constructed to highlight the following. If some population groups have systematically lower scores, meaning we somehow have a distorted reading of the scores for them, then it costs less to skip their best scoring members in the name of diversity. And this runs contrary to the nature of the diversity objective itself, which is to equalize access to opportunity. This also represents unfairness, and this is why I labeled this problem as a fairness problem, under a particular belief system that we have to make explicit. Suppose that the scores represent effort. For example, how hard someone studied on a test. We may then take a relative view of effort, asserting that scores are more informative within a group than across groups. Further, we may assert that it's important to reward effort, so a higher score is better and should be rewarded. Taken together, these beliefs correspond to a Locke egalitarian conception of equality of opportunity, which I'm representing here with a rainbow unicorn, which states, of course, both how wonderful it is and also how unrealistic. But there is something we can do in this particular setup. Consider the set of 4 candidates that I'm highlighting in blue. This set still meets the diversity constraint, and its score is just slightly lower than the score of the pink set. This utility loss is inevitable, but it's very small in this case and in many other realistic cases. The blue set contains the top scoring candidates of both genders and the top white and Black candidates. And so it's much better in terms of rewarding effort across groups, not only within one particular historically advantaged, historically privileged group. Having stated our beliefs, the Locke egalitarian beliefs that I'm reporting here, and having observed the trade-off between diversity, utility, and fairness, we are now ready to design an intervention. So for example, one plausible intervention is that we may compute unfairness for a group, like the female candidates that I'm showing here, as the ratio of the score of the lowest scoring selected candidate, and that is candidate K with score 83, to the score of the highest scoring skipped candidate. This is the candidate that is the least happy, and that's candidate D in my example with score 95. We can then reformulate the selection process to balance unfairness across groups. We did this and quite a bit more in the paper. This was an HCI paper last year, where we designed several fairness metrics of this sort. So this is actually one of them, for both set selection that I just described and also for ranking. We also developed an integer linear program that encodes all of these constraints, and we ran experiments showing that the utility cost of balancing fairness of this kind is low in most cases. For a systematic treatment of fairness in ranking and a mapping to equality of opportunity frameworks and more, please see an upcoming survey that I co-authored with Maike Zelike and my PhD student Kei Yang, that will be coming out on arXiv in a couple of weeks.
Julia, can I ask a question?
Of course.
So in your previous example, if we assume that the process or the function or the algorithm that generate these scores are fair, and by that I mean we know that they are agnostic to applicants or individuals' gender, and to proxy variables that are actually not admissible, then suppose a company has happened to have like more qualified males than females, then I can imagine that enforcing this diversity would actually introduce individual level bias, because in order to enforce that balance, you need to ignore qualified males.
So
do I make sense?
Yeah, of course. Yeah, these constraints are given as input to us. right? So if you can in fact assume and you can verify that the score distribution is independent of gender or of race, then it is not warranted to be using diversity constraints, and this fairness problem furthermore won't arise. So what's happening here? Yeah.
So somehow assume the scores are not generated in a fair manner, or there is, I don't get this part. So you assume the scores are not necessarily fair, and this exhibited itself in, go ahead.
Yeah, so what is assumed here in the slack egalitarian worldview is that, so let me just give a summary of this worldview, I guess more precisely. What is assumed is that a person's performance is a combination of two sets of factors. Those that they are accountable for, that represent effort, and those for which they are not accountable, that represent their historical disadvantage at birth, for example, or through life that they have been experiencing. Furthermore, a lack egalitarian worldview, equality of opportunity worldview, assumes that effort that people exert is relative to their group membership. In other words, if you're born in an affluent environment with access to tutoring and all of your peers study really, really hard, then you're gonna be studying much harder than somebody who's born and raised in a housing project where it's actually not encouraged to study, right? So the worldview that we are talking about here is one where we are assuming that the playing field is not level, and that our goal is to arrive at a state where the playing field is level. And there's a lot of disagreement in the literature about how to do that, right? So one set of disagreements is whether to consider effort relative to the group or absolute. Another is how do you split up these factors for which you are or aren't accountable. But in your example that you gave, Babak, you said the playing field is already level. And so I agree with you that if this is the statement that we make, if in fact our society is such that there is no racial bias, there is no gender bias, there is no bias with respect to individuals with disabilities, then we don't need to enact diversity constraints, and these types of fairness issues won't arise either. So just to kind of drill in on the fairness here, what's happening here is that we are seeing an intersectional concern, meaning it only arises if there is membership in two protected groups simultaneously, like in my example here, gender and race. And then your utility drops disproportionately if you are doubly disadvantaged. And this is what we're trying to control, essentially. Make sense?
Yeah, thank you.
Any other questions since we stopped?
Julia, I have a follow-up question. This is very interesting and very thought-provoking. So one of the thoughts is the score here, it's one-dimensional. In reality, we always have multiple characteristics, that multiple metrics, right? In many of these hiring decisions, they would look at, I don't know, how to use academic metrics. We talk about number of publications or the quality of the publications, quality of the talk, and all of these, so many different metrics that hiring committees consider. How would this complexity of this problem, how would it generalize, and how would the feasibility of the approach that you talked about generalize to multiple dimensions of criteria?
Yeah, so this particular problem is looking either at set selection or at ranking. And in both of these cases, you need a score to be computed in some way, according to which you sort. And this, in some sense, is the simplest case. So what I'm showing you here is that the score is given to you is just a number.
Right.
I'm not assuming anything about the selection process itself. I'm just saying if my objectives are such that I want to have diversity and at the same time maximize utility, no matter what method I use, if there is a systematic difference in the score distributions, I will, in my selection, disadvantage further people who are already disadvantaged. And specifically, this occurs, again, as I told Babak, what we're assuming here is that there are at least two, and possibly more than two, sensitive attributes here, according to which there could be discrimination. Now, if you have multiple attributes, right, we're just going back now to my distorted image of the world picture. And these are very realistic situations that we see all the time, right? So kind of maybe to depart from hiring and go to college admissions, a GPA is indicative of something. An SAT score is indicative of something. And the types of distortions that we have been seeing in the data are something like girls systematically have lower math SAT scores than do boys. So this is what we see in the data. But by just looking at that, we don't know why that is. And one line of reasoning that is consistent with the results is girls are not as good at math compared to boys. Another line of reasoning says, no, actually girls are not as encouraged to do math and their parents don't hire tutors for them, right? So both of these assumptions are going to be supported by the data. The data doesn't refute them. And so then the question arises, and this is kind of the most difficult question here. If we can't formulate a falsifiable hypothesis here about why this bias arises, what can we do? And the point is we have to just state our beliefs up front. So the belief that I will state about this is there is a disparity in treatment for which girls are not accountable and that we can counteract, right? And another person might have a different argument. But importantly here, and what I like about this specific example, which is really deceptively simple, is that there is no AI here to speak of, right? There's nothing hidden here. I know what the scores are. The data is open before me, and yet I am seeing these effects. So all the complications that we see with these really, really complex black box models, discrimination and what we should do about it or not do about it, this all already exhibits in these very simple, deceptively transparent gadgets that are score-based rankers, essentially.
Sounds good. Let's continue. Thank you.
One quick comment, and I want to know your take, Julia. So I'm going to be fast. So, if the imbalance between qualifications of males and females, if we observe that there is an imbalance between them, and that imbalance is as a result of lack of equality of opportunity in society. So the question is to what extent that particular application or algorithm is responsible for taking this imbalance into account.
Great question.
For example, if it's a hiring algorithm, maybe it has nothing to do with the company. The company only cares about qualifications. If there is some sort of imbalance going on in the real world as far as lack of opportunity goes, why should we hold that company accountable for taking into that sort of inequality of opportunity into account? Like,
which company now, the vendor of the solution or the employer that is using it?
The employer.
The employer. So this is why I started this conversation by talking about regulation, right? And essentially what we have going on today is that everybody says, oh, it's not my fault, it's the data. Or it's not my fault, says the vendor. The employer told me that these are the metrics that I should maximize. And ultimately, the only way that we can control what in fact goes on is by passing regulation and holding companies to account. And of course, individual decisions are not going to either, completely fix or completely break what's going on. It's easier to break everything kind of at one step than to fix. So if at a particular stage in the funnel, somehow not enough women are passing through, and then we're going to adjust our thresholds and we'll make it so that enough women pass through, that still is not going to help the entire pipeline. It's not going to help even if women make it all the way through. It's not going to help those women who didn't get a sufficient level of education to succeed in that position, right? So every step can break what happens, but to actually make the playing field level, it's not enough to go and debias your data or go and increase your thresholds. But it certainly is helpful, I think, and this is one of the roles that a technological solution can play, is it can surface these effects for us. We can actually use it to diagnose what's going on, and then can match what we have diagnosed with our belief system and say, this is a problem, or no, I'm okay with this, because I actually think that people are accountable for their scores. And this is why I'm showing here again the mirror picture with its limitations, that, yeah, you can try to debias, but that's not going to make it so that people whom you admit actually succeed in college long-term necessarily.
Thanks, Rita.
Sure. Okay, so let me maybe switch to a couple of other things here. So I skipped a few other examples where we also talk about diversity and set selection in a similar environment, but with slightly different sort of technical insights. What I want to fast forward to a little bit, because I think I'm out of time or almost out of time, is that This picture that I've been showing you has a beautiful clean data set, a predictive analytic, and then an output, right? And so if our goal then is to figure out how to make it so that the output is, say, more balanced, that more women are present in it compared to their proportion in the input, or that we can explain what goes on in this entire framework, then we need to step away from this frog's eye view and look more closely at what happens inside this magic box, understand better how these results are used, whom do they benefit and whom do they harm, and also ask where the data came from. And once again, this puts this kind of expanding from the frog's eye view, puts these problems closer to our comfort zone in data management. So here are a couple of examples of things that could go wrong and that we in data management have an opportunity to help mitigate. So suppose you have your resume screening stage, there's a data set, a predictive analytic, and an output. And you find that women are underrepresented in the favorable outcome groups. They are not getting hired or they're not getting promoted. You could try to fix the model, sure, of course. But maybe if you knew that the input, this square or rectangular data set, was created with select star from programming language expertise where language is C++ and experience greater than 5 years, that data set itself, the result of this query, contains 10% females, then it may be better for you to try and rewrite the query so as to get more women in the input to your predictive analytic. For example, lowering the required experience from 5 years to 4 years. Here's another example. Suppose that predictions are less accurate for recent college graduates. We can try to fix the model, of course. But what if we actually learned that college transcripts could give useful signal in addition to resumes? And so we would need to go back to the data acquisition step and look for additional data sets that contain college transcripts. So once again, we're stepping outside of the scope of a mitigation that is do something with the input, tweak the box, or tweak the outputs. As my final example, suppose that we have fewer applicants from historically Black colleges and universities than expected according to their graduation rates. Should we try to fix the model? It's unlikely to help. So instead, what we should do is go back to the data sharing step and help data providers share their data while adhering to laws and upholding the trust of participants, of job seekers in this case. In other words, we will gain much more power to incorporate responsibility, by which I mean ethics and legal compliance, into ADS if we see these systems through the lens of the data lifecycle. And this is one example, one possible example of a data lifecycle. Responsibility concerns and important decision points arise in data sharing and annotation, acquisition and curation, cleaning, integration, querying, and ranking. And we will miss opportunities for improving data quality and representativeness, for controlling for bias, and allowing humans, oops, something happened.
Something wrong, Julia?
Yeah, something happened with my screen, sorry, just a moment. Allowing humans to oversee, I was gonna say, the results if we look at all of these processing stages. In their 1996 paper, really a classic at this point, Friedman and Nissenbaum identified 3 types of bias that can arise in computer systems. These are represented here by a 3-headed dragon. And these types are pre-existing, technical, and emergent. The type of bias we've been talking about so far is pre-existing bias, bias in the data that has its origins in society. The second kind is technical bias, and it can be introduced at any stage of the ADS lifecycle. Importantly, it may exacerbate pre-existing bias in the data. The bad news is that we, in the work that we do in this community and in the earlier lifecycle stages, have lots of opportunities to introduce technical bias. But the good news is that because we were the ones that introduced it, there is also no question about whether we should try to fix it. If we break it, we fix it. If technical systems we develop are introducing bias, then we should be able to instrument them to measure it, to understand its cause, and to mitigate it. And then the final kind is emergent bias. This is something that arises in the context of use of a system. A prominent example here in web ranking or recommendation in e-commerce is rich get richer, where searchers tend to trust the system to show them the most appropriate, the most suitable items, say at the top positions of the ranked list, and then which items they see at the top forms their understanding of what a satisfactory answer looks like. In all cases, any attempt to fight bias must begin by us stating beliefs and assumptions explicitly. This is because there often simply isn't a falsifiable hypothesis that one can state, as was the case that we discussed before about math SAT scores. So with this, I want to very briefly, maybe in 3 minutes or so, and then we can go to a discussion, highlight some concrete methods for taming technical bias, where I think really lots of opportunities and lots of low-hanging fruit are for our community in particular.
Julia, feel free to go on till 4. That's fine. We can
Yeah, but I do want to have a conversation with people. I feel like.
Okay, sure.
Okay, so let's see. Let me get through this and then we can decide whether to continue. So my example here is a data scientist in a human resources department at a large retailer, think Walmart. This data scientist, her name is Anne, is developing a model that predicts the level of compensation to offer to successful job applicants. What should be the amount that we offer to them so that they accept the position. Anne is going to include candidates' self-reported demographic data and their employment histories as input. Then, following her company's best practices, Anne will start by splitting her data set into training, validation, and test. Then she's going to do a bunch of pre-processing. She's going to join the tables, interpolate missing values. After that, she's going to do model selection, tuning, and validation. And next, Anne is going to look at the accuracy of the trained model, and this is supervised learning, and she will observe a disparity. Accuracy, prediction accuracy, is lower for female applicants. And this presents another kind of a fairness issue. Now, this is more about process fairness rather than outcome fairness. It's a disparity in accuracy rates. Considering the complexity of this data processing pipeline, Anne has a long night of debugging ahead of her to understand the cause of this and to attempt to correct the disparity. So what should she do? Anne goes back to data pre-processing and observes that the value of the attribute age is missing far more frequently for women than for men. And so she's going to interrogate data interpolation, missing value imputation. She's going to compare age distributions by gender and notice differences starting from the mid-30s. Anne will revisit the data cleaning step and select a state-of-the-art data imputation method to fill in age in customer demographics. And this is going to help her achieve higher accuracy for the female population. Now let's extrapolate from Anne's experience and list some other sources of technical bias that may arise during data cleaning due specifically to incorrect modeling assumptions. Consider a form that gives job applicants a binary choice of gender and also allows them to leave gender unspecified. And suppose that about half of the users identify, or the applicants identify, as men and half as women, but that women are more likely to omit gender. And this, by the way, is a very plausible situation. We are here in the context of employment, right? So people, if they feel that they are being discriminated against based on their age, being older, or based on their gender, being female, then they will be more likely to omit that value. And similarly with disability status, folks who are disabled very rarely state that they are disabled for fear of discrimination in particular. So now suppose that half, again, of the applicants are men and half are women, but that women omit their gender at higher rates. Then if we use mode imputation, replacing a missing value with frequent value for that feature, which is the default in scikit-learn, for example, then all unspecified gender values that are predominantly for women will be set to male. More generally, multi-class classification for missing value imputation typically only uses the most frequent classes as target variables. And this leads to a distortion for small population groups because membership in these groups will never be imputed. This is technical bias, textbook. So next, suppose that some individuals identify as non-binary. Because the system only supports male, female, and unspecified as options for gender, these individuals will likely leave gender unspecified. Again, if mode imputation is used, their gender will be set to male most likely. A more sophisticated imputation method will still use values from the active domain of the feature, setting the missing value of gender to either male or female. This example illustrates that technical bias can arise from an incomplete or incorrect choice of data representation. Finally, consider a form that has home address as a field. A homeless person will leave this field unspecified, and it's incorrect to attempt to impute it. And while dealing with null values is already known to us to be a difficult and important problem, and we already look at it and think about it in data cleaning, the responsibility concerns here introduce new problems with much higher stakes of a mistake. And importantly, it has been documented that indeed data quality issues such as missing values often disproportionately affect members of historically disadvantaged groups. And so we risk compounding technical bias that is due to data representation with pre-existing bias for such groups. And there's some work that Sebastian Schelter and I and our students are doing on systems that allow data scientists to find causes of technical bias and to mitigate it through pipelines. So I won't dwell on this here. The last thing that I will show you, because this is again one of my favorite gadgets, is interpretability is very important. Public disclosure, interpretability for data scientists, for decision makers, for auditors. And we've been running with this metaphor of a nutritional label to enable interpretability and public disclosure. And here I'm showing a nutritional label for rankings. It's a tool that we implemented that runs. Please play with it. It talks about what we think the recipe is for the ranking. This is for score-based rankers. What actually matters in a ranking, that's the ingredients. And it also quantifies diversity, fairness, and stability over ranking. So let me wrap up here, just so that we have a bit of time for discussion. Stability is a fascinating topic. We have some papers on this together with Abola Sude. Please take a look. And the takeaways really is that it's all of us. We all are responsible. We are responsible to educate ourselves about these issues, think about them, so that we can come to a situation where technology indeed is rooted in people, and where we can explain to our kids what we do and why it matters. And my last point here is that the images are from a comic book. It's the first volume in a series. The volume is called Mirror, Mirror. It was created, I created it together with Fala Arif Khan, who is the very talented artist and a student. And you can see it at Data Responsibly GitHub.io/comics. And I also teach a course on responsible data science. It's a technical course. All my materials are online. Please use them and let me know what you think. Data Responsibly GitHub.io/courses is where you find that. And our comic is fully accessible with a screen reader. And we just released a Spanish version of it, a Spanish translation. So that's that.
Great. Thank you, Julia. And that was really interesting and very beautifully presented talk with the images from your comics. I read your comics a while ago. It's very educational and entertaining. I was really impressed. I'd encourage the audience to go take a look at it. Let's see if we can give you a round of applause. Of course, we do this virtually nowadays. I'm going to put that on the participants list. And open the floor for questions from the audience. Please raise your hand if you don't unmute yourself.
Can I go first?
Go for it, Babak.
Thank you. So is there any technical definition for technical bias? If not, is it fair to say any sort of operation during the data science pipeline that distort the underlying distribution of data, make it not representative of the population that we want to deploy the modeling?
Yeah, so that would be roughly the definition that I would give. But in addition, I would also say that it's not any distortion. It's a distortion that we care about. So if we're talking about fairness here, then there is a set of demographics that we care about and that we need to watch for and that we need to protect. So a distortion in shoe size maybe is going to be less relevant than a distortion in proportions of race and gender. But otherwise, yes, I don't think there is a concrete definition, really.
I agree. That makes sense. Which kind of suggests that there is a close connection between a statistical bias and societal bias of the model, right? They're not necessarily the same, but they're connected.
They are connected, but a distinction, or I guess a way to show that they are not one and the same, is that we very often introduce statistical bias, as you know, to fight societal bias.
Absolutely.
Right? So we might actually deliberately oversample or undersample in a particular portion of the input, or do something more sophisticated like what you guys do in your Capuchin paper, right? Where you introduce statistical bias to correct for societal. And you have to do this deliberately with stated assumptions and stated goals for these interventions so that you can check whether in fact the thing that you did worked by some definition of worked.
Absolutely.
Yeah.
Okay, more questions from the audience?
I have one. As I was listening, I was thinking about the discussion between Julia and Babak, and this idea whether there is an assumption of bias between groups, whether there isn't any. And I was thinking from a pure technical point of view, it would be interesting, and I suspect it is true. You can probably prove that if you make the bias assumption and it doesn't hold in your particular setting, then the algorithm that looks at groups and looks at relative effort within groups will give you the same utility as the algorithm that discounts the groups.
Indeed. And in fact, there is actually work that, well, we're doing some of that right now, so we don't yet have really kind of concrete results. But the idea here is that not only would you be able to make a statement that everything is legitimate if you had exactly the same outcome, say, but also if you know a bit more about your models, you can say that I'm going to be mitigating to make it so that now the outcomes are in proportion to the proportion in the input of the different demographic groups, right? This is statistical parity that we want. Under particular modeling assumptions, you can make it so that you correct the actual concrete outcome while still being within kind of the bounds of uncertainty of your statistical model. So you could have gotten that result purely by chance, but it just so happens that it's a fair outcome for this particular instance. So you can play tricks of this sort, certainly. And this is something that's not been explored very much. Meaning I'm reordering up to noise, right? It matters for these college applicants today, which of them I admit and which I don't. But under my assumptions about the model that generates the data, I could have actually derived this particular result.
Right, I agree. But I want to emphasize slightly additional point of view, namely one which would actually point towards defining what it means for an algorithm to be fair.
Mm-hmm.
And first of all, it would be elegant to not have to apply different algorithms depending on different assumptions. would be nice if the same algorithm applied with a bunch of assumptions about bias would just degenerate into the bias unaware algorithm without changing anything. And a proof that this is true about an algorithm would, in my eyes, show that the algorithm itself is unbiased. And everything is about the assumptions that I feed into it. And then I can have my beef with the assumptions and discuss those. But basically state that the algorithm itself, working from these assumptions, what it does is fair.
So algorithms, it's usually not the algorithm, it's usually the data, really. Right? I mean, there can be some effects where an algorithm amplifies what you find in the data, but the algorithm itself is not going to be usually to blame. I mean, maybe you're making the margin a little bit wider when you're classifying, but otherwise there isn't really going to be anything up to the algorithm. The kinds of assumptions that you state, the kinds of goals that you phrase for the algorithm, that definitely is going to impact your fairness and your performance, right? So you're saying that if your data distribution is such that you could derive a fair outcome without any interventions, that your algorithm should kind of fall back onto that solution. Is that the idea? Maybe I'm not following exactly.
I'm thinking more along the lines of, let's say, algorithms for pseudo-randomness, where that this algorithm simply cannot distinguish. Any consumer algorithm cannot distinguish between a true random generator and a pseudo-random generator.
I see.
So in this case, yeah, I would try to come up with a notion of what it means for the algorithm to be fair, so that I can put the blame just at its input. And when doing so, I was thinking that an important part of this agenda would be to be able to state these assumptions in some sort of high-level language that then can be fed into the algorithm, because right now a lot of this is just baked in.
Right. We certainly should be separating the assumptions. We should be separating the objectives. One additional thing, Aline, is that I talked here specifically about 3 notions of fairness, kind of one of them implicitly and 2 explicitly. One of them was proportionality in outcomes. I called that diversity, just to give it a different name. Another was a balance in the loss of utility per group. I called that my fairness intersectional case. And then there's another one that I talked about under technical bias, and that is achieving equal accuracy rates. And already just looking at these 3, you can see how they are of different kinds. And there are cases where you won't be able to achieve all of them. So for example, if you constrain yourself to having just one classifier, there's this well-known result that says that if the prevalence of the phenomenon you're trying to predict differs in the subpopulations, say by race, and your classifier is accurate, it's well calibrated, then you cannot simultaneously equalize false positive rates and false negative rates across groups. So equal error rates is a kind of a fairness, right? It's a process fairness condition. And we know that in many, many cases, we in fact just cannot expect these notions to be compatible.
Julia, can I jump in? But you know that all of these definitions based on the statistical notions, they have been already disputed, right?
Everything is being disputed,
right? except for one language, which seems to be exactly what Alan actually envisioned. So we should not define fairness. We should define a language, a formal language, so that we can use that language to communicate with policymakers or social scientists to essentially formalize in a particular context, what do they mean by fairness, and we would be able to enforce it into the algorithm.
Right.
And then everything is up to those assumptions, and it has nothing to do from that point to the algorithm. And that language seems to be causal inference, right?
There's any number of ways in which you can try to abstract. right? So one place where this all fails is when, and this is when we're fooling ourselves really, is that there exists some kind of a common framework with which we're going to be able to express all of these concerns that society has been thinking about, such as fairness in outcomes, fairness in process, fairness to an individual, fairness to a group, justice in society. These are all very comprehensive, very loaded terms. And we, including us, including me, are only just starting to scratch the surface of what these mean, right? So what I talked
Yeah,
about
absolutely.
today is that there are different ways to think about what we have been thinking as algorithmic fairness in this very constrained community. And that is essentially the fat community in machine learning plus its expansion. But there's a lot more out there, right? And one size is not going to fit all. One language is not going to fit all. We can attempt. This is what we have been doing also, is carving out a niche where there is some way for us to come to kind of a common way to explain what these fairness notions are. And this is why I gave these different breakdowns, right? That there's pre-existing, what are the kinds of it, and then there's technical, it's a different beast from pre-existing, from emergent. But it won't be helpful for us to start with a kind of an assumption that there exists this uber fairness notion somewhere or an uber modeling notion. And again, that's not a falsifiable hypothesis, right? This is my point of view at the moment. That is going to take us all the way.
Absolutely. Yeah, I just want to make the point that this impossibility results in fairness, which kind of suggests that, or the community take those results as if fairness is impossible in general. There's always these like notion of fairness that there's a competition between them. I don't agree with.
So you know what that specific impossibility result actually says? The main assumption there is that you have a single classifier that you have to build, that you're going to be running that same single classifier for your subpopulations. And the reason that this assumption is being made, that you cannot have a separate classifier for the African Americans and for the whites, specifically in that case, is that in the US, we have a doctrine of disparate treatment that tells us that you cannot treat individuals differently based on their race, no matter what it is. And so disparate treatment tells us you cannot, as a bank, have separate classifiers for the poor and for the rich. You, as a criminal justice system, cannot have a separate classifier for the Black individuals and for the white, right? So what that impossibility result actually talks about the impossibility of reconciling equality in accuracy with the disparate treatment doctrine.
Yeah, I agree. But another thing to think about is having an imbalance in accuracy of the model is not necessarily an indication of discrimination. Maybe it can be explained by other factors. That's another thing to think about.
Yeah, I mean, there's always a plausible explanation, right? So to me, an imbalance in accuracy is one of these concerns that I've been calling process unfairness. This is actually a due process violation.
Yeah, but here's the thing. It could be just a correlation between lack of accuracy and a protected attribute. And that correlation could be explained a bit by a third factor.
So you're talking about causality now, Babak, and you are preaching to the choir. We also are working on causal methods. And the reason that I like causal methods is because they make explicit the assumptions that you state.
All of the other notion of fairness that do not use causation, they are already making assumptions that are actually more unrealistic than assumptions that we make in causal methods.
No, I agree with you. I agree with you. And we've been working. I'd be curious to know what you think about our latest paper that talks about intersectional causal fairness in rankings.
Yeah,
it's with Josh Loftus. It's been a really fun project.
I read that paper. That's a very nice one, and it is an important. In that paper, you have two kind of treatments, and then these treatments interact with each other. It's a well-known problem in causality. I'm glad that you looked into it in the context of fairness. It's an interesting paper.
So, Julia, I have a slightly different question for you, non-technical. From your interactions with these regulators, right, in the city, what lessons do you have for computer scientists in terms of how we can approach, how to teach regulators about this sorts of issues? Yeah, Congress is famously ignorant about technology. Right. They don't even know how Facebook gets its money. So what is your lessons from that interactions? What are the pitfalls we should avoid? What are the things that actually work?
Thank you for asking this. I've actually been spending, I was just thinking this week, I spent more time talking to non-expert, non-technical audiences about like, what's AI? And I have this nice little slide deck that says, now, suppose you're baking sourdough bread and here's your rule-based AI and here's your Roomba, it's kind of like this. And suppose you're now learning from how it tasted. So my main lesson is it's not their fault that they don't know this. I think we need to find ways to teach them, because it's much easier for us to learn what they know, because their stuff is written in English, than it is for them to learn what we know, because they can't read our papers. And this is actually something that I realized a few years ago in conversations with technology lawyers, that it's, you know, their papers are long, but they're written in beautiful English. So the burden is on us. They call this in law the least cost avoider. For whomever it's easier to do something, they are the ones who are responsible for stepping up. For policymakers, it's an unsurmountable task to try and understand what AI is. So it really is on us to engage in these efforts. That's one. Another thing that I learned is that kind of crudely, the difference between law and policy. Policymakers are much closer to us because they take these concepts that are embedded in laws and they translate them into a set of rules that they can then execute. Like, oh, achieve an equitable distribution of resources in your city. Okay, that means I take my budget and I count how many libraries there are and I split it up equally among the libraries. So they are, in a sense, writing these programs. So it's fairly easy to talk to them. And it's fairly easy to learn what it is that they're trying to do. And there are lots of opportunities there for our tools to actually make a difference.
I see.
And another thing that we can contribute is that we have, and we've been criticized for this as a community generally, but we have this reductionist point of view, right? We know how to abstract things. We know how to think in terms of levels of abstraction, how you package all into your carburetor box so that the fewest wires are sticking out. And in law and policy, they miss that skill. And so by talking to them and actually helping them figure out that they're mixing different concepts, this is very insightful to them. Yeah, but ultimately, frankly, the work with policymakers, they are people and we are people. And they have incentives that they don't always state. Many of them are political appointees, right? So like what happens when there is something like, oh, now we have a law passed in New York City to make government operations transparent. Yay. So I come to the table, I'm like, okay, let me give you a tool and here's how we can do data transparency. And they're like, no, there's privacy. So they don't actually mean what they say lots of the time. And this is really tough. So you just have to kind of figure out who are the good actors, who are the bad face actors. And
wow.
Yeah.
Okay, sounds good. Sounds like it's going to be a long journey. It's not a sprint. It's going to be a marathon.
But it's fun. It actually is fun. I feel like this is where we can make a lot of impact.
Sounds good.
And it gives you real problems also to write papers about.
Cool. Okay, so let's thank Julie. I think we are out of time now. We have to head to the other meeting. So Julia, we will switch to the other Zoom meeting. Let's thank the audience. Thank you for showing up to the seminar. And again, thank you, Julia, for visiting us and giving this wonderful